Hello and welcome to our lesson on classifying polynomials. So this lesson is basically going to be a vocab review, or maybe some new vocab for you, but it's going to be a good way for us to brush up on some terminology or get to know some terminology before we actually start some of the real math. Okay, so we're classifying polynomials today, but before we talk about polynomials, we need to distinguish between expressions, equations, and functions. Again, just some vocab to get us started. So in math, we often group together numbers and variables, and when we do this grouping of numbers and variables, we can create an expression, we can create an equation, and we can also create a function. Okay, and the reason it's important to distinguish between these three types of things is because the directions, or what we do with each of them, is going to be different. Expressions, for example, are things that we would simplify, equations would be things that we would solve, and functions are generally things that we graph. Okay, so what does it mean for our numbers and variables that we group together? What does it mean for them to be an expression? Well, if it's just an expression, that means we do not have an equal sign. So expressions do not contain equal signs. So maybe like, I don't know, x minus 5 would be an example of an expression. Now, if you throw the equal sign in there, then you're looking at an equation. So equations contain equal signs. They do contain equal signs. So maybe we make this an x minus 5 equals 4. Okay, x minus 5 equals 4 is now an equation. Now, if your equation contains two variables, then you could have what we call a function. So functions are types of equations. Functions do have equal signs, but they demonstrate a relationship between two variables. So if this was a function, maybe it would be something like y equals x minus 5. Okay? And the x, the minus 5, the 4, the y, these different parts of our expression or equation or function, we call these the terms. So the numbers and or variables that we separate by plus or minus signs are called the terms of our expression or equation or function. Okay? Now what we're going to be focusing on in this module and the next are polynomial expressions. And a polynomial expression is just a specific type of algebraic expression. So it's an expression. Now what's going to make it a polynomial expression versus some other type of expression? If it's a polynomial expression, then the terms cannot be under radicals. They cannot be in absolute value symbols. They cannot be in denominators of fractions. Okay, and the terms in our polynomial cannot contain variables on their exponent, cannot contain variables with exponents that are fractions. So I don't want to see any fractional exponents, or negatives. I don't want to see any negative exponents. Okay, so I have some examples of polynomial expressions. So these three are polynomial expressions, and this first one has two terms. So terms are separated by pluses and minuses. So I have a term here, plus I have a second term here. So this first one is an example of a polynomial expression with two terms. Can't spell. With two terms. Okay, the next one we have a 4x squared minus a 5x plus an 8. This would be a polynomial expression with three terms. So this one has three terms. And then in the last guy here, we've got a 10x y to the fourth plus a 7x squared y minus a 3x and then minus a 9. That's 1, 2, 3, 4 terms in this polynomial. And I know that these are all polynomials because they follow all of the rules I just mentioned. Okay, none of the variables have exponents that are fractions or negatives, and none of the terms, none of those parts that we just counted up are under radicals, are in absolute values, or in denominators of fractions. So just for an example, so you can see, this 2x minus or 2x plus 1 is a polynomial. If I made it 1 over 2x plus 1, it's no longer a polynomial. It's what we would call a rational expression. If I took the 2x plus 1 and I put it under a radical, Okay, even though the 2x plus 1 is in there, because it's under a radical, we would call it a radical expression. It's no longer a polynomial. Or if I took the 2x plus 1 and I put it in an absolute value, so absolute value of 2x plus 1. Again, this is no longer a polynomial. This would be called an absolute value expression. Okay, so all these in the other colors here, even though they include the 2x plus 1, because the 2x plus 1 is in the bottom of the fraction or under a radical or in an absolute value, it is no longer a polynomial. So, and I'm not so concerned that you know these names. I don't want you to freak out about those, but just so you can see a few more non-examples. Again, if my 2x plus 1 became a 2x to the, let's say, negative second power plus 1, that's no longer a polynomial because we can't have negative exponents. Or if we had, let's say, 2x to the 1/4 power plus 1, we don't want any fractional exponents as well. So all of these guys in this little bubble, okay, these are not polynomials. Not polynomials. Some non-examples. Okay, so hopefully that makes sense. So from here, what we were going to look at are some more specific names for our polynomials. So polynomial is like a very general blanket name, like take the word car, for example. Okay, car is a pretty generic name. We know there are lots of specific types of cars. For example, we could look at a family of cars made by Toyota, and then Toyota produces, the Tacoma, or Toyota produces a Corolla. So there are specific names depending on, what the make and model are of the vehicle. So polynomials sort of work the same way, where polynomial is this overarching name, like a generic name, like the word car, and then we can classify them more specifically based on some of their characteristics, just like we can name specific cars. Okay, so let's talk about some of these specific names here. Polynomials can be classified, which is named more specifically based on two things. They can be named by the number of terms that they contain, and they can also be named by their degree, which may be a new concept for you. The degree of a term is going to refer to the number of variable factors in that term. And that sounds fancy, but factors are like multipliers. How many variables are being multiplied in the term? So for example, this 3x to the 4th term, technically 3x to the 4th means 3, and then x to the 4th means I'm multiplying x by itself 4 times. That means x is a variable factor 4 times in that term. So we would say that this degree has this term has a degree of 4 because it has 4 variable factors. It has 4 x's in there. Okay, this 2xy squared, I could write this out as 2 and then x, y, y. That's 1, 2, 3 variable factors. So we would say that this term has a degree of 3. Okay, and then the last one, the 8 there doesn't have any variable factors. So no variables. That means no variable factors. That means technically it has a degree of 0. Okay, so we have to be able to look at a polynomial and determine how many terms it has and determine the degree of each of those terms. Now the degree for the entire polynomial is going to be determined by the term that has the highest degree. For instance, if we look at 3x to the 5th plus 2x to the 4th minus 7x plus 1. Well, this x to the 5th here tells me this term has a degree of 5. And then this x to the 4th here tells me this term has a degree of 4. And then we have an x to the 1st here, so this term has a degree of 1. And then the 1 that doesn't have any variables tells me this last term has a degree of 0. Okay, so I have the degree for each of the terms. Now the degree for the entire polynomial is dictated by the term that has the highest degree. So since the term with the highest degree is 5, we would say that this polynomial has a degree of 5 because 5 is the highest. So the whole polynomial has a degree of 5. Okay, so similarly here, the first term has two x's and a y, that means the first term has a degree of 3. And then the second term has 1x and 1y, so the second term has a degree of 2. And then the third term has a degree of 1. There's just 1x there. So since the 3 is the highest, we would say that the entire polynomial has a degree of 3. Okay? So if we can tell how many terms are in our polynomial, and we can tell what its degree is based off the term with the highest number of variable factors, then we're going to be able to give our polynomial some more specific names. 2 names, in fact. One for the degree, one for the number of terms. It'd be like a first name and a last name. Or we could say like it's a Toyota Tacoma, right? If our polynomial has a degree of 0, then we're going to call that a constant. If our polynomial has a degree of 1, we're going to call it linear. And maybe that would look familiar to you if you just want to think about this for a second. If you have any experience with something like y equals 2x plus 1, y equals mx plus b form being a line when we make a graph, it's linear because we have a degree of 1 next to the first power there. Okay? Just to maybe throw back to something you've seen before. If we have a degree of 2, that means we have a quadratic. If we have a degree of 3, that means our polynomial is going to be called a cubic polynomial. And then the good news is after a degree of 3, there are some specific names. They just aren't used commonly unless you're like super math nerd, and that's not me. I don't use them, and we don't typically hear them a lot. So a degree of 4 technically is quartic, and degree of 5 is quintic, but you're just not going to hear those terms a lot. After a degree of 3, we're going to say non-specific. So after 3, so that's what I said here, beyond a degree of 3, it's going to be non-specific. So a degree of 4, we're just going to call it a 4th degree. Or a degree of 5 would be a 5th degree. Or a degree of 6 would be a 6th degree, a degree of 7 would be a 7th degree, and then they would just continue on with the nth degree depending on what n was after 3. Okay? Now if we have a certain number of terms, again, we can be specific. So if we have 1 term, it's still a polynomial, but we can be specific and call it a monomial or monomial, however you want to pronounce that. Single term. If it's got 2 terms, we can call it a binomial. Should make sense. If it's got 3 terms, maybe you're guessing, a trinomial. And then the good news is, again, after 3, it's non-specific. So if it's got 4 terms, 5 terms, 6 terms, any number of terms after 3, we're going to keep it with the generic name, which is just a polynomial. Okay? So polynomial, and again, anything after 3 is going to be kept with that non-specific name, the very generic name, like the word car, very generic. Okay, so let's try classifying a couple of these. Let's start by identifying the degree and the number of terms, and then give it a name. So this first example here, because that term has a degree of 1, and this term has a degree of 0, the term for this polynomial, or the degree for this polynomial is 1. So the degree is 1. And it has 2 terms. So if it has a degree of 1 and it has 2 terms, its name would be a linear, that's for a degree of 1, and binomial, that's for 2 terms. And it doesn't really matter the order that you name those, but typically we put the name by degree first, like binomial, linear would sound a little strange. So this is a linear binomial. Now, it's totally okay to just call this a polynomial, but because we can give it a more specific name, we would. Just like if I saw a Toyota Tacoma on the road, or a Toyota, let's say, Corolla on the road, I could just call it a car. But I want to be more specific if I can and say that's not just any car, that's a Toyota Corolla or whatever it is. Okay, so we're going to call this a linear binomial. Okay, next one, let's see, we've got a degree of 2 here, degree of 1 here, degree of 0 here. So this entire polynomial has a degree of 2. The degree is 2, and it has 1, 2, 3 terms. So because it has a degree of 2, we're going to call it quadratic. And because it has 3 terms, we're going to call this a trinomial. Again, polynomial is a perfectly acceptable name. This is a polynomial. We're just being more specific and calling it a quadratic trinomial. Okay? How about 8x to the 4th? Let's see. 8x to the 4th has a degree of 4. And a degree of 4, and then, let's see, just one term. So if it's got a degree of 4, we're going to be non-specific and call this a 4th degree. And then one term would be monomial or monomial. So a 4th degree monomial. Okay? How about here? We've got a degree of 3, degree of 2, degree of 1, degree of 0. So we'd say the degree for the entire polynomial is 3. That's the highest. And then it's got excuse me, 1, 2, 3, 4 terms. So degree of 3 is going to be called a cubic. And then 4 terms, we're going to stay non-specific and say polynomial. So cubic polynomial is as specific as we could get with the name for this guy. Okay? How about this next one? We have, let's see, 2 x's and 5 y's. That means this first term has a degree of 7, and this term has a degree of 0, so this entire polynomial has a degree of 7, and it's got 2 terms. So we're going to call this 7th degree, and it is a binomial. A 7th degree binomial. Okay? And then number 6, just a 12. What's going on here with the 12 is, well, we have a degree of 0, no variable factors in there. So this degree is 0, and it's got just one term. So we're going to call this a constant. And technically it is a monomial. And there's that. Okay, now it's not like super imperative, like you're going to fail this class if you don't have all of this vocabulary memorized, but this is vocab that I will use, so it's going to be helpful for you to familiarize yourself with it. And probably the type that we're going to be seeing the most of are these quadratics, quadratic trinomials specifically. So if you really could put that into your head, that x squared is a quadratic, or that a degree of 2 is quadratic, that's going to be probably the most important one for you to try to stick into the memory. Okay? The rest of this is just nice to know information. Just because, again, I will be using this vocabulary, and it's nice to for it to ring a bell when I say something, right? Okay, so the last little piece here is that when we are looking at a polynomial, we typically want them to be in what we call standard form. And in their standard form, polynomials are written in what we call descending order. So if the polynomial is in standard form, it's written in descending order. That means the degree of the terms should be descending from highest to lowest. So the terms with the highest degree go first, and then we descend down to the lowest, which means if we have a constant, it would always be at the end, because that would have a degree of 0. So the degree of the terms should descend from highest down to lowest. So if we look at this first one, we've got a degree of 2, degree of 3, degree of 0, and degree of 1. So the term with the highest degree, which is the 9x cubed, that should be first. And then the next highest would be the 8x squared, so that should go next. And the next highest would be the 2x, that should be next. And then the 0, the term with a degree of 0, which is the minus 3, that should be at the end. So in the correct descending order, that's what that cubic polynomial would look like. Okay, and then this last guy, we've got a degree of 2 here, an x and a y means a degree of 2 here, and then a degree of 2 here. So technically, this polynomial could be left in the order as is. If all of the terms have the same degree, then you can leave it as is or rearrange them any way you like, because all those degrees are the same. So this could stay the same. It is already in descending order. Already good. Okay, so that's it. Little vocab lesson to get you started. When you get into the practice assignment, Hopefully the terminology is going okay for you. If you find yourself struggling, however, feel free to reach out. I am here to help.